I'm going to walk you through the thermal energy transfer practice so that you can get ready for your pre-assessment. And if you earn a 70% or greater on your pre-assessment, then you will automatically start on level 2 when we start standard 2. So it's worth your time to look at this and pay attention. So the big questions that will be answered through this guide would be: what makes something hot or cold? How do things get warmer or cooler? And to answer these questions, we're going to go ahead onto our next slide. Down here in the corner, click next. What is thermal energy? All matter is made of particles that are in constant motion. The energy of motion is called kinetic energy. All particles do not have the same amount of kinetic energy. So when we measure temperature of a substance, we're finding the average kinetic energy. Remember, kinetic energy is the energy of motion, and you definitely can tell that these particles are moving. And the thermal energy of a substance depends on its temperature, as well as the quantity of particles it contains. A cup of water and a pool of water may both have the same temperature, but the pool contains more thermal energy because it contains a lot more water. So thermal energy flows from warmer areas to colder areas. Heat is a measure of this flow. The transfer of thermal energy can occur in 3 ways: conduction, convection, and radiation. So you get a chance to see what happens to these particles at a lower, colder temperature. And I think you can notice at a colder temperature, the kinetic energy is decreased. And let's see what happens at a hotter temperature. They are going to move much faster. Conduction transfers thermal energy through direct contact. So here we have a pot of water directly sitting on top of a flame. So you're going to go ahead and click on this video and you can go ahead and watch that. Some materials, such as metals, are better than others at conducting thermal energy. So an example of that would be if you were to put a metal spoon in this pot and you went to touch that spoon, it'd be very hot. And because metal conducts heat very well. Sometimes pot handles are made of metal, and if you were to touch the pot handle, you would get burned. Sometimes the pot handle is made of a different material that does not conduct energy. So while you wouldn't touch the actual pot because that would be too hot, you could touch the handle in that case and it would not be too hot because the material doesn't conduct as much energy. Convection is demonstrated in this little video, so you're going to go ahead and watch that. And convection, we think of currents when we talk about convection. So you will actually be able to see that the hot water is going to rise and then it's going to cool down. It's going to fall back down again, get towards the bottom here, touch the flame, get hot again, and just rise and fall, rise and fall. So that's another way that energy can move through a substance. And we remember that heat rises, and as the temperature cools, it falls and creates convection currents, which will be very helpful for you to understand how the heat transfers on the inside of our Earth. Radiation would be thermal energy through waves. You're going to watch this video here, and radiation can carry thermal energy from object to object, even though there's empty space. So when waves carry the energy from one place to another through, it could be air, it could be water, but that would be radiation. And another example of that might be the sun. The sun is very, very hot. It's very, very far away from Earth. But because of radiation, the heat of the Earth radiates through the air and then our atmosphere to reach us. And that's one example of radiation. And when we discuss Earth science, we'll talk about some other examples of radiation. So here we have the sun warms the Earth. What keeps our planet at temperature that can support life. Why are some parts of the planet warmer than others? How does transfer of thermal energy relate to earthquakes and volcanoes? So the sun warms the earth. Let's go ahead and click on radiation. So here are the example of the waves that are hitting the earth. And you can see that in some places, there's number one, the sun is the energy source. Number two, some solar radiation is reflected back towards space by clouds on the Earth's surface. 3, Earth also emits thermal energy into space. So you can see here that some of that energy is going back into space, and that greenhouse gases trap some thermal energy in the atmosphere. Okay, convection. We can see the convection currents, and here we have, let's see, the sun warms Earth unevenly, and the areas near the equator are heated more intensely than the polar areas. Convection currents in the atmosphere distribute thermal energy around the Earth. So here we have number one, this is the sun heating the Earth's surface. Then we have the heat moving on the surface. We also have this kind of figure eight pattern going through the ocean, because in the ocean we have hot and cold water that moves and keeps currents going in a particular direction. And then this little section here is a little cross section where you're looking into the earth, and that's really what we're going to be focused on, is how the center of the earth, which is very, very hot, causes convection currents in this area that we call the mantle, and then we'll find out how that changes the surface of the earth. And then finally we have conduction. Most conduction occurs in the Earth's surface during the day. Solar radiation warms the ground and the water, and then the air heats up by touching the ground and the water. Okay, in a campfire, we have conduction, where the metal rod would not be a good choice for roasting marshmallows. So here we have number one. I guess she has a metal rod because that's going to conduct heat up to her hand and burn her. If you've ever used a metal rod, sometimes you may notice that your hand doesn't get burnt. Certain types of metals do not conduct heat as far or as well as other types of metals. So if you have a really long metal marshmallow stick, you may notice that your hand does not get burned. If it was much shorter, obviously it would. And then this person has a twig from a tree, and wood is a poor conductor of heat, and his hand is not going to get hurt. Convection, you would have the air around the campfire being heated, and the hot air rises, and then the cool air falls, and you would have those convection currents, even though you can't visibly see them around the fire, but they are there. And then radiation would be the thermal energy. If you're standing away from the fire, obviously you don't want to touch it, but you can feel some of the radiation, the heat radiating off of the fire to you and keeping you warm. How do you stay cool on a hot day? How about conduction? So this person's feet are touching a cool floor, and actually if his or her feet are warmer than the floor, then the heat's going to go from the feet to the floor. Some people have floors that are actually heated, so in the wintertime, the heat from the floor would go into their feet and keep their feet nice and comfortable. Convection. So even though you can't see the currents, but especially if you are on the second floor of your house, you may notice that it's much warmer because convection currents cause the hot air to rise. So if you're in the upstairs bedroom, it would be much warmer than if you were on the lower level because the cool air sinks. And then radiation, the heat, if the outside temperature is warmer and you're cooler, the heat's going to be moving towards you, and vice versa. If you are or our body temperature is 98.6. But on a hot day, we're going to heat up, but on a cool day, we can lose that heat due to radiation. Okay, solar energy in your house. How can your house be designed to take advantage of the way that thermal energy is transferred? So what can happen with your house? Conduction. You could add insulation to your house so that the inside is not touching the outside, and you kind of leave that space to keep your house cooler. Convection, the thermal energy, keeping it moving through your house. So some people have fans on the inside where they can move the hot air down so that it cools off, and then you could use that convection current to your advantage. And radiation, we're receiving radiation from the sun's rays, so maybe you could put up window coverings that would actually block those rays from entering your house. Some of you might have those types of curtains in your house that keep your inside cooler. So hopefully you can go through this little interactive and learn more about conduction, convection, and radiation. So when you take your pre-assessment, you can land yourself right on level 2. Thank you.